Alright, so in this particular video, we have a 3 kilogram steel ball. It strikes a massive wall at 10 meters per second at an angle of 60 degrees with the plane in the wall. And in this instance, it bounces off with the same speed and angle. Alright, so here's the diagram. Here's the ball that's going to strike it at 60 degrees relative to the wall, and then it ricochets back with the same speed and the same angle relative to the wall again. Alright, so this is pretty symmetrical. Part A, B, and C. Part A asks us to find the change in momentum in the x direction. So let's go ahead and set the statement up. Change in momentum is final momentum minus initial. But you notice here in my work for part A, everything has a subscript x because it sets it wants it in the x direction. So here I have delta px equals pfx minus pix. So as long as you are careful with your subscripts and focus just on the information in the x direction, you cannot mess up on part A. All right. Well, the generic definition for P or momentum is just mv, but here this is pfx, so I can rewrite pfx as m vfx because it's just mass times velocity. Likewise with pix, I can break pix down into mass times the initial velocity in the x direction. And then from here we can just use geometry and hopefully crank this part A out. Okay, so here in the diagram it says the speed is 10 meters per second. So I'm just going to label this arrow here. It has a length of 10 meters per second. So because this is a vector pointing northeast, I know it has to have a horizontal velocity component, which I need because part A just focusing on the x direction only. So here I'm just going to call this angle 30. Keep in mind that the angle given is touching the wall, so this is 60. So the angle touching this and the horizontal component is 30 degrees because it has to add up to 90 degrees. I'm just going to find VIX. Okay, so finding VIX, hopefully by now in physics, you know how to find components. To find VIX, you simply take the hypotenuse, which in this case is 10, times the cosine of 30. I use cosine because it's the angle touching the horizontal axis here on my VIX. So you notice here in my work, I have VI times cosine of 30. Once again, I highlight 30 because I just like to use the angle that touches the x-axis. This way, x is cosine and y is sine. So if you punch in 10, which is for VI, times cosine of 30, you'll get 8.66 on your calculator. Okay, so I know VIX is pointing to the right, and it has a magnitude of 8.66. Now, the other thing I do need is the VFX, right? Because right now I'm just focusing my attention on the x direction. Well, it also states that it rebounds off with the same speed, which is 10 meters per second. However, this vector here is pointing northwest, so it has to have a horizontal component pointing left, and then due to symmetry, it's also the same because this angle here, watch where this angle here is 60, so therefore this angle that touches the vector itself in the horizontal x-axis here is 30, which is also the same angle where my cursor is currently resting, so that's also 30. But hopefully you're not overcomplicating it. It's pretty symmetrical. So if this VIX on the bottom is 8.66, VFX in this case would have to be the same magnitude, except it points leftward because this vector is pointing left and up. So you notice here in my work, I have VFX is equal to negative 8.66, and it's negative because it's pointing left. So I'm just going to plug and chug. Okay, so here I'm just going to factor out M just to keep my work a little shorter in terms of plugging and chugging. Both these terms have an M. I'm just going to factor out M. So we can really say the change in momentum in the x direction is the mass itself times the change in velocity in the x direction. So I just figure out what VFX is. VFX here is just negative 8.66. Okay, so this negative sign is essential. Okay, if you don't put the negative sign, you're going to jack up your work. So VFX is pointing leftward, so therefore it's negative 8.66 minus VIX, but VIX is pointing right, so it would just be 8.66. So here we have a negative 8.66 minus another 8.66, and that would just give us the difference of negative 17.32, and then we can just multiply that mass, and the mass being 3, which is given in the problem. Okay, other than that, calculated work time, you'll get a change in momentum of negative 51.96 kilograms meters per second. And you notice here, once again, I highlight the negative sign here because the change in momentum in this case is indeed negative. Okay, all right, so that is the answer for part A. Part B. Part B asks us to find the impulse experience in the y direction. Why it uses the term impulse really is asking the same thing as part A. Impulse is the change in momentum. So the terminology here shouldn't throw you off. Impulse is exactly the same as change in momentum, but except it wants it in the y direction. So I'm just going to set up the same physics, except I'm going to focus my attention in the y direction only, okay? So here I have change in momentum in the y direction is equal to momentum final in the y direction minus the initial momentum in the y direction. Likewise, I'm just going to go ahead and break it up into mvfy minus mviy. Factor out an m likewise. So therefore, change in momentum in the y direction is just mass times the change in velocity only in the y direction. Well, you notice here I need VFY and I need VIY. So let's go ahead and find VIY first because the problem starts down here. So here the arrow that just came on the screen, okay, that is my VIY. My VIY is pointing upward because my initial vector is pointing up and to the right. So VIY here would simply be VI sine 30. Once again, I like to use this angle 30 down here. Okay, that's up to you if you want to use 60. If you use 60, then it would be what is that? Cosine. Okay. So once again, I like the 30. So if you punch in VI being 10, because it said so, and then sine of 30 is a half, 10 times a half is just 5. So we know VIY is a positive 5. And then due to symmetry up in the bottom of the diagram here, this vector in the final frame is going to the left and up. But due to symmetry, I know that VFY must be the same magnitude. And as a matter of fact, it actually also points in the same direction. So if you watch my cursor, VIY is pointing upward, and that's 5. But this arrow here is also pointing upward, and it's 5. So really, it hasn't changed, right? It's positive 5, and it's still positive 5. So I'm just going to go ahead and plug values in here. M is 3. VFY is a positive 5. Minus gets carried down. And then VIY itself is a positive 5. So in this case, 5 minus 5 is just 0. So 3 times 0 would just give you 0. So what is the change, or what is the impulse experience in the y direction? The answer is 0. It's 0 because, well, the mass hasn't changed. VIY is the same as VFY, so which suggests that the final, or the velocity in the y direction hasn't changed. If the velocity in that direction hasn't changed, there is no impulse experience in that particular direction. Okay, so you can just reason it out. I just show you how to do the math to prove that it actually is 0. Let's go ahead and crack out part C. Part C here says if the ball is in contact for 0.2 seconds, find the average force exerted by the wall onto the ball. All right, so in this case, if you just kind of use common sense here, the ball is moving to the right and up, and then in order to cause this ball to change direction, the force would have to point leftward, okay? So the force exerted on the ball by the wall would be the normal force, and the normal force in this case would be pointing away from the wall, which is left. So keep that in mind as you get an answer. Here, I'm just going to apply impulse here. Impulse by definition is force times time, which is equal to change in momentum. Once again, change in momentum here is just impulse. So here you have two different statements for impulse. So I set this up. Why? Because I need to find F. Well, I know what the time is. Time is given as 0.2 in part C. And change in momentum, we already know. Well, there's only change in momentum in the x direction because we already established that change in momentum in the y direction is 0. So in terms of delta p, the only direction that contribute to delta p here is just in the x direction. So my delta p simply comes from delta px. All right, so I'm just going to plug and check. So delta p is simply delta px, which is negative 51.96. Delta py is 0, so it doesn't do anything. Delta t here is 0.2. So if you simplify this on your calculator, you get a value of negative 259.8 newtons, which makes sense. And I do want to point out that once again, the force exerted by the wall onto the ball needs to be pointing leftward, because in order to change the ball's direction, you have to push in the opposite direction. Okay, and in the opposite direction of positive would be in this case negative. All right. Other than that, that is the answer for part C. And I'm going to keep the negative sign because it's just average force. It did not use the term magnitude. All right, stay nerdy. Don't be whack. I hope that helps. Oh, real quick before I forget. Well, I did forget. These types of problems mathematically proves what multiple choice questions could be. Okay, so I found this particular question online, and it's just an example of how to apply this concept just conceptually without doing any math. So hopefully, now that you see my math, you know what the answer is. So here it says a steel ball strike, blah, blah, blah. Pretty much is the same scenario, but you notice here there's no numbers given, right? And it asks only for which vector indicates the direction of the net change in momentum. So you notice here it says net change in momentum. Well, if you kept up with my work, there was change in the x direction, but there was no change in the y direction. So really, there's only change in the x direction, and it has to point left because we calculated already, and my value for p delta px is a negative value, right? And then delta py was 0. So really, this particular question is super easy to answer. It's just so the net change in momentum here would just be pointing leftward, because the only direction that has an impulse is the x direction. All right. So once again, hopefully the math helps validate these types of multiple choice questions. You can pick it really quick. Okay, now stay there. Don't be whack.